guys. All right, so now we're going to talk about exponential modeling. Oh no, I'm going to yawn. Sorry. That's different than linear modeling, which is what we did in 9B. So let's talk about exponential. I have shortened this section a lot from what it was originally. So I've shortened all the homework questions to reflect these questions here. There are some, more like explainer, kind of think about homework questions too. But if you have any questions about those, again, feel free to reach out to me. Remember, linear modeling increases by the same absolute amount each time. So the prices of gas is going up by 4 cents per week, or the price of a house, this isn't necessarily a good example, but the price of a house could go up by $2,000 exactly each year. That's linear modeling, the same absolute amount increase. Exponential modeling is like the opposite of that. It's always a percentage change. So it's the same relative amount. It's a change relative to what it was the previous year. So hopefully that makes sense. It's kind of like when we did those problems with like simple interest and compound interest. So simple interest was the same absolute change. That would be like the linear modeling. And compound interest is the same relative change. Remember, it increased by a percentage every year, but remember with compound interest, you made interest like on the interest from the year before. Kind of the same thing here. And we have an equation that's going to look very similar to you, and of course you can use this equation on the test. You can use all these worksheets on the test and on the homework. So there's no memorizing, but I'm going to show you like why the equation works, and I think you'll be able to figure out why. Exponent, there's an exponent in the equation, so I'll show you what I mean. All right, let's look at the worksheet. Oh, I just got a case of the yawns. Sorry. Let's talk about the equation Q equals Q initial times, that's not an X, it's a times, 1 plus R to the T. I can't remember if they called it T or Y. So you might recognize this kind of looks like the equation when we had like principal times 1 plus the interest rate raised to the number of years. It's almost the exact same thing. This is like our new value that we're looking for. This is our initial value, where it started. What did we start with? How many people did we have? Then this is times. This is just the number 1. It's a constant. Represents 100% of this. And then this is your rate. And it's, as always, as a decimal. Oops. That's like too many parentheses, but you get what I'm trying to say. And this is your time in years. So you could have even written like a Y here. So it's very, very similar to one of those equations we did in chapter 4. So let's look at that equation and let's look at number 1. If a city's population started at 10,000 people and grew by 2% each year for 6 years, what is the population after the 6 years? And use this equation. So if the city's population started at 10,000 and it grew by 2%, don't forget to change this to a decimal. You're going to get like crazy big numbers. For 6 years. Throwback to order of operations. Remember, you have to do what's in the parentheses first. So I'm just going to copy down 10,000 and I get 1.02, and you have to raise it to the 6th power. So let me do it on my phone calculator. Oh my goodness, I'm so sorry. You guys are like, stop. So if I do 1.02 to the 6th, you would get 1.126162419. Okay. Remember, you're taking that now and you're multiplying it by 10,000. So leave that number in your calculator and just say times 10,000. I have to go this way with it because I'm in a room. So I get 11,000, right? Essentially, I'm moving the decimal over 4 places. I get 11,261.6. I'll stop there. Because they asked what is the population. That's fine. We can leave it at They might ask you for population in whole people. Leave it like that. Or they might ask you to round it to the nearest 10th or 100th. Just make sure in my math lab, whatever they ask you to round it to is how you round it correctly. On the last test, there were a bunch of rounding errors. And when I go through a second time and look at the test, I always pick up on the rounding errors. So don't think you're losing like a full point if you just rounded to the wrong decimal place or something. I'll go through and give you partial credit. And you can see that. Remember, in my math lab, on the left-hand side, there's a tab and it says Gradebook. You can click on that, you can see your tests, and it will even let you review each question and see how many points out of the total, or what percent out of the total number of points on that question you could get. So they're all worth 1 technically, and then at the end they like weigh them all evenly. So if you got like a 0.95 out of 1, right, that's like maybe not even a point, if that makes sense. So feel free to ask me though. Again, if you have questions, just ask, just communicate, that's all. So that's the answer for number 1. Let's talk about number 2. It's too late to have coffee. It's dark outside. Let's look at number 2. So this one, they're talking about a rainforest. Sorry, just a regular forest, but still. A privately owned forest that had 2 million acres of old growth is being clear cut at a rate of 7% per year. This is decay, right? This isn't growth. This is decay. So you're going to need a negative number, right? And they tell you in the bottom where R is greater than 0 for growth, meaning it's a positive number, and where R is less than 0 for decay, meaning it's a negative number. That's all. So just make sure where your R value is. You substitute either a positive or a negative number, and this number 2, it is decay. So you're going to need a negative number there. So you can go through that, and your Y value, this is again just like the question we did number 1, your Y value, or your T value, sorry, it was called Y in chapter 4, and now it's called T. It's all the same thing, time in years, will change based on 1 year, 5 years, or 10 years. See how they have you do it in different years. So, all right, what about number 3? I like this one. We'll do this one out. In 2018, I just made this up, but the average price of a home in a main town is $309,000, but home prices are rising at 4% a year. Predict what the price will be in 2025. Okay, then use the same information to predict what the price will be in 2048. All right, let's do this. Spoiler alert though. This isn't going to happen, right? And we know it's not going to happen now because things are probably heading down with all of this stuff that's been going on, right? Home prices will never rise at a constant rate for forever, right? Sometimes they'll rise really quickly. The slope or the curve might go really steep, and then they'll rise more gradually. Sometimes they even might decline if there's a recession or something like what we're going through right now. A pandemic, of course, would make people more unsure. A lot of people are losing money right now, so they could be losing their homes, unfortunately, as well. Of course, that's what we're trying to prevent, but all of these things will change what happens with home prices. But let's talk about this specific example. So if the price in the year 2018 was $309, in 2025, how can I figure out what it will be using my equation? Q equals Q initial times 1 plus R to the T. Well, what's my Q initial? That's pretty easy to figure out. It's 309. What did the price start at? Okay. 1 plus, what's my R? What's the rate? It's 4%, right? And since they're rising, it's positive. And what's my T value from 2018 to 2025? It's 7, right? 18, 19, 20, 21, 22, 23, 24, 25. It's 7 years. So let's do that math. 1.04 to the 7th times 309. Do that math out on your calculator. I'll do it too. I didn't pre-do this. I like to kind of do them with you sometimes. Oh shoot, I messed up. 1.04, clear. 1.04 and then turn. Remember, it's that X to the Y button if you're on an iPhone calculator. Okay, so I got 1.3159317792 ... And then I'm going to say times 300, times 3, oh my goodness, times 309. The buttons are too small for my fingers. So I got 406,622 and 92 cents. Sure, throw it on there. Okay, that's fine. But what about 2048? What's the only thing that needs to change? It's your t value, right? What will the t value be now? You're going from, remember, 2018 to 2048. You don't start with this. You go back to your original. This is probably a good point to make. You go back to your original and find the difference here, because this means initial. What is the very beginning of the data? That's that 309. I guess it probably wouldn't even matter, actually, now that I think about it out loud. So let's do 309. Well, I already did it. It's already done. We just need to change our t value, which is what? From 2018 to 2048, your t value is now 30. Okay, 30. So 1.04 raised to the 30th power times 309,000. Okay, so when I did this, raised to the 30th, I got 3.24339,751. And then I multiplied that times 309, and I got 1,022. Oops, sorry, 002. Oh, it's just my dog coughing. 20983. Over $1 million. Over $1 million for that. Pretty intense. All right. Good. That was number 3. If you have any questions about that, let me know. Let's look at number 4. Read through number 4. Really think about it for a minute. And remember, we're not talking about absolute growth. We're talking about exponential. This is not linear. So it's a little different. Read through number 4 for a sec. I had to think about this one too myself. If prices increase at a monthly rate of 2.1%, so meaning the first month it goes up by 2.1%, and the next month that new amount goes up by 2.1%, and then the next month that new amount from the month before goes up by another 2.1%. See what I'm getting at? It's not just 2.1% 12 times, right? That would be linear growth. But this is not. This is exponential growth. This is like compound interest, same idea. So by what percentage do they increase in a year? This is kind of like those APY equations we did back in the day. Remember we said, well, sort of, kind of. It's more like compound interest to me. So I'm going to use the same equation just to keep it consistent. Okay. If instead of thinking of a year as 12 months, if you think of each month as like its own year, its own time period almost, we can use this equation thinking, okay, that interest is going to increase like upon itself 12 times. So I can use this equation and say, okay, I'm going to do this now for each month. So if I wanted to do it for each month, I can say 1 times, well, I know my interest rate is, and I'm increasing for 12 months. I know, but you're like, well, it's really just 1 year. Yes, but think of almost each month as its own time period or as its own year. Okay, so instead of now talking about time in years, I'm saying, okay, well, this is for each month. Well, what's my initial value though? We don't have one, right? So this is gonna be where I'm just gonna make something up. I'm just gonna say I start with $1,000. At the end, I'm gonna compare what I get to what I started with, and I'm gonna come up with a percentage. So effectively, this number that I don't know and this number that I'm just making up are gonna cancel each other out. Just like what we did back in the day with the APY equations, annual percentage yield, similar to that. So just pick any number. I just picked 1,000 because it's an easy number. So now we'll do this math and we'll find a new number, and then I'll show you how we'll compare them. So I get 1.021, and I have to raise that to the 12th power, because remember, it's happening 12 times over 12 months, each month. So when I do this, and I raise it to the 12th power, I get 1.28, 324, ... I'm going to just leave the whole number in your calculator, though. There's no rounding. Now I have to take this number and multiply it by 1,000, so I'm going to do that too. So I get 1,000, I'm moving it over 3 decimal places essentially, $1,283.24. Okay, so that is my Q value. Okay, but you're like, well, this was a number you made up, so what the heck do we do with this number? So we need to find the change now. We're trying to find a percentage change, right? So if I find out how much money I made and I divide it by how much money I started with, I'll be able to figure out what the percent difference is. Write this number down here. I'll write it up here. 283.24. And I'll write my Q initial as $1,000. All right, we gotta erase the board. Pause it if you aren't done. So if I say, okay, my Q value minus my Q initial divided by my Q initial, doesn't this look an awful lot like percent increase or percent decrease? Yeah, it is. I can find the percent increase for the whole year. So if we just do the math and we say 1,283.24 minus 1,000 divided by 1,000, I'll end up with 283.24 divided by 1,000, and I know essentially I'm moving my decimal point 3, so I'll get 283.24. So the percent change is 28.3%. Remember, I divided by 1,000, and then I just had to move it back over because we were trying to get it to a percent. Hopefully that made sense to you. If not, feel free to reach out to me and I can try to explain that a little better. All right, that wraps up chapter 9. We're going to totally switch gears in chapter 10, but I love chapter 10 because I have a fun problem about pizza and how to get the most pizza for your money. And I bet if I just ask you the question initially, and I will ask it to you initially in chapter 10, I bet most people think it's the other answer. So I'll show you that coming up in chapter 10. Hope you guys are doing well. Let me know if you have any questions. Talk to you soon.